Select the major product of the following reaction. So in order to decide the product of a reaction, we need to decide what type of reaction is occurring. And so we want to look at what are we starting with and what are we reacting it with. So we have a secondary benzylic halide here. Secondary 2 bonds to carbon, benzylic, because that leaving group is on the carbon directly attached to a benzene ring. Okay, so with a secondary benzylic halide, the reactions that we have seen so far of our alkyl halides, including benzylic halides, are substitution and elimination reactions. And so the secondary benzylic halide, we actually have the full suite of those reactions possible to us. A secondary benzylic halide could undergo an SN1, an SN2, an E1, or an E2. Okay, so we're gonna really need to look at what we're reacting this with to narrow down the pathway. So we see that we're using ethanol. And so ethanol, like water and methanol, other alcohols, is a weak nucleophile and a weak base. So what that means is that that's going to shut down these concerted pathways. Your concerted pathways need either a stronger nucleophile or a stronger base to initiate the reaction and get it going. So because we see that it is a weak nucleophile and a weak base, we're going to eliminate those concerted pathways. So now we want to consider that this could be either an SN1 substitution or an E1 substitution, or an E1 elimination, I'm sorry. Heat would favor that elimination pathway. And there's also some hints here in the product. An elimination pathway would give you an alkene, and we might notice right away that none of these options are alkenes. So we're definitely looking at an SN1 pathway here. So to get to the products, let's go ahead and draw the mechanism. So the first step in an SN1 mechanism is your leaving group will leave. And we did start with a chiral center, but we're going to lose that chirality in this first step, because when this leaves and forms a carbocation, your carbocation is flat. It is sp2 hybridized and trigonal planar. So we have a flat carbocation. So once we add our nucleophile, it'll become a chiral center again. We're going to get a mixture of enantiomers because our nucleophile could approach from either side. So our nucleophile in this case is the ethanol. And so this can approach, and we know that that can approach from either side. So you're going to form a new bond between this oxygen and that carbon. It's going to approach with equal likelihood from either side. So we're looking at either C or D. At this point, if you've seen enough examples, you might recognize that after this, the next step is going to be remove a hydrogen. So you're going to have the ether. So you might be able to, at this point, jump ahead and circle D. If you're not sure how I got there, I'm going to finish off the mechanism here. So let's take a look at what forms after that approach. So we have formed a new bond to the oxygen. We still have a bond to the hydrogen and a bond to the ethyl group, which means that oxygen has a positive charge. And so to get rid of that positive charge, this is an acid, we're going to remove the acidic proton. And so we're going to use another equivalent of the ethanol. The ethanol is something that we have a large amount of. It is both the nucleophile and the solvent in the reaction. So we have a lot of it around. And then we remove that hydrogen, we are going to be left with the ether. And because this can approach from either side, you'll have about 50% with that bond being on a wedge and about 50% on a dash, indicating that racemic mixture of products.